Alright, so we went over the factor theorem, remainder theorem yesterday. We reviewed synthetic division and a little bit of the long division. So now we'll do the rational zeros theorem. So suppose f is a polynomial function of degree n greater than or equal to 1 of the form f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 0. I'm shortening it a little bit. With every coefficient an integer. Yeah. And a sub 0 is not equal to 0 if x is equal to p over q is a rational 0 of f where p and q have no common integers, or no common integer factors, I should say. Other than plus or minus 1. Then p is an integer factor of the constant coefficient a sub 0, and q is an integer factor of the leading coefficient a sub n. Did we decide on a quiz on Friday? Here. This Friday? Okay. Do you want to take your quiz on Thursday before you leave then? Rather than having to wait and take it when you get back and try to remember everything? Okay. So I'll have the quiz ready for you to take it then. Oh, we decided on test. Never mind, it'll be a test. I mean, if you, well, do you have a study hall? Yeah, okay. We'll probably be done with everything tomorrow, so if you have any questions, like review-wise, you can ask them, and then Thursday, they'll review, and you could just sit in the computer lab and take it during class if you want. That's how you can knock it out. Garrett, do you have a question? Right here? Yeah, n minus 1. Friday. He's just not going to be here, so I'm going to let him take it on Thursday so he doesn't have to wait and try to remember everything when he gets back. Next year I won't have a lot of room to talk, so. I said next year I won't have a lot of room to talk. I don't know. I want to go to Hawaii, but we'll see. Alright, the last thing then, note-wise, and then we'll do some examples of these things. For upper and lower bound test of real zeros, so this is essentially looking at how to know if something's an upper bound or a lower bound. Like thinking back to like the boundedness stuff that we did. So let f be a polynomial function of degree n greater than or equal to 1 with a positive leading coefficient suppose f of x is divided by x minus k using synthetic division. If k is greater than or equal to 0, and every number in the last line is non-negative, so that means that it would be either positive or 0, then k is an upper bound for the real zeros of f. If k is less than or equal to 0, and the numbers in the last line are alternately non-negative and non-positive. So alternating, like plus minus. Or a 0 could be in there because it just says non-negative or non-positive, so it doesn't say that it has to be positive and that it has to be negative. 0 works as well. Then K is a lower bound for all the real zeros of F. So basically we set this up as synthetic division, and then if we get them where the whole last line is either positive or 0, it's an upper bound, assuming that K was greater than or equal to 0. If K is less than or equal to 0, and then it alternates between positive or 0 and negative or 0, then K is a lower bound. What? Rather than the symbol. I don't know if that just helped anything or not. I think for the sake of time, because we don't really use like long division, honestly, that much, any problems that would involve long division we're just not going to do. We're just going to do the ones that involve synthetic. It's more useful. It allows us to see more things as we've seen. It can help us to find the upper and lower bounds, the different, like the rational zeros and stuff. We can, well, we don't necessarily need synthetic division for that, but we can see stuff with that. From that, the factor theorem, remainder theorem, all that kind of stuff we can see just by using synthetic division, or just like that setup. So I think I'm just not going to give you any problems that are long division. I mean, I might give you like one problem on the test that's like extra credit long division, but I'm not going to necessarily spend time going over that. So if y'all want to make a note of that, there might be an extra credit long division problem. If y'all want extra credit. Anyways. But we're going to go through and do some examples probably for the rest of class, and then I'll go ahead and give you the homework. So like Melcher, if you want to work on the homework tonight so you can ask questions tomorrow to be ready for the test Thursday, that's fine. Otherwise, you'll have class tomorrow to work on these problems. And then Thursday review, Friday test. Monday and Tuesday next week might be a movie day since it's just... Huh? No, it's a math movie. But it's you'll think like it's a good movie though. Stand and deliver. Favorite line from the movie. It's decomposing in my locker. You'll find out what that means later, but it's a good movie. It's funny. So basically about a bunch of kids who were not very good at math, and their teacher turned them into really, really good math students, and they all did really, really well on their AP exam. So, yeah, anyways. We might do that next week rather than starting a section. I'm not 100% sure, but I have the movie, so. And y'all didn't get to watch it last year, so. So I think I just watched that movie by myself at home. I don't even know what it is. That movie you're talking about. All right. Since I'm not going to give you the long division problems, 1 through 6, you would just, well, it's only 1 through 3 you could do by synthetic division, so you would do those ones the same way, though, as you do the problems like 7 through 12, so I'm not going to do another one of those right now just for the sake of time, but if we have a little bit at the end, I'll go back and do one of those again. Alright, so 27 through 30, well, we did do the factor theorem and remainder theorem examples yesterday, right? Okay. The factor theorem and remainder theorem examples. We did them yesterday in the notes. So 27 through 30 says to find the polynomial function with leading coefficient 2 that has the given degree and zeros. So basically, you are going to write out a polynomial that has all of those things. You might remember doing this a little bit last year. I think we did it when I said, like, here's the zeros, write the function. I think we probably only did it with something that was quadratic rather than something that's higher than that. But 28 has a degree of 3. We have -1, 3, and -5 as zeros. And it says that the polynomial function will have a leading coefficient of 2. So that should, I think, hold on a second. Well, we'll go ahead and work out the problem. So, if these are zeros, what are my factors then? Let's see if we remember that first of all. Yeah, so I would set it up as x plus 1 times x minus 3 times x plus 5. And I need to multiply this stuff together. So multiplying the first two, what do I get? Okay, yes. You just did it, yeah. Alright, and then this one. Need to multiply this stuff. Am I done? Based on what the instructions said, am I done? Said I have a leading coefficient of 2. Am I done? How would I get a leading coefficient of 2? Multiply it all by 2, so I need to multiply this whole thing by 2, so I get 2x cubed plus 6x squared minus 26x minus 30, and now I'm done. Okay, so don't multiply by 2 to begin with. It is possible, depending on what your factors are, that it may already give you a 2 in front. If it were to give you a -2 in front, what would you need to do? Yeah, multiply a -1 all the way through to get rid of that. Okay, are we good with just one example of that? It's really just multiplying after you set the factors up. Okay. We may have, I don't remember. I'm pretty sure we did it in Algebra 2, but I can't remember. That's possible. Okay. Let's see. Alright, So the next thing says to use the rational zeros theorem to write a list of all potential rational zeros, then determine which ones, if any, are zeros. Okay, it's possible that we did this last year. I don't remember for sure. Okay, so our rational zeros theorem, okay, basically we need to factor I think I'm looking at the wrong problem. We need to figure out if P is an integer factor, or, sorry, getting ahead of myself. We're going to figure out then if P is an integer factor. The only common integer factors can be 1 and -1. They can't have any other ones. And then we're going to figure out if Q is an integer factor of the leading coefficient A sub n. Does it tell you what we're dividing by? No. Oh, okay. Whoop. Let's see. 34, we'll start with that one. Probably not a ton. I don't know how much. Is that all the room you have left? Oh. If you write on the right side, yeah, you should be fine. Alright, f of x is equal to 3x cubed minus 7x squared plus 6x minus 14. Okay, so basically with this, if these were already 1 or -1, okay, essentially all you have are those options, so you would just check both of those by plugging them in, and if they're not equal to 0, then it doesn't have any rational zeros, okay? But with one like this, these are not 1 or -1, so we need to see if there's any common factors between these. So I'm looking at a leading coefficient of 3 and a constant coefficient of -14. Okay, make sure you keep the signs with it. So by the theorem, we have potential zeros. We do the factors of -14 on top over the factors of 3 on the bottom. So what are my factors of -14? Okay, I want them all listed out. So 1, 2 is a possibility. Okay, and notice they are all plus or minus. Okay? Okay, is that all of them? I'm just asking, making sure we check them all. Okay. So, I'm just going to let you know there is a possibility some of these problems could have like 20 factors. Okay? So, you have to check all possible ones, and then factors of 3. Yeah, plus or minus 1, plus or minus 3. So, then I need to list out over here all my possible factors, okay? This is not done. I need to actually go through and list them out. So, I'm going to actually write them down here because I don't think I'm going to fit them all. I have 1 over 1, so that's plus or minus 1. I have 1 over 3, so that's plus or minus 1/3. I have 2 over 1, so that's plus or minus 2. 2 over 3, so that's plus or minus 2 over 3. 7 over 1, so I got plus or minus 7. Plus or minus 7 over 3. Plus or minus, I still don't have room, 14. And then plus or minus 14 over 3. These are all possible factors of this. Okay? Now, I don't think most likely you want to sit here and check 1, 2, 3, 4, 5, 6, 7, 8, 16 factors by hand. Do you? Not really. All right, grab your calculator. All right. So, I want you to graph this original function here. Okay, so your y equals, stats people, actually everybody might need to. Make sure your plots are off. Okay, I don't remember if I don't think we ended up graphing those problems in here unless y'all did that while I was gone. Those stat plot problems. Anyways, so type that into y equals. Okay, and you're going to want to make your window go all the way out from x values of negative 14 to 14, or I would say negative 15 to 15. So you're going to, after you zoom 6, change your window for x to be from negative 14 to 14. Okay, and I'll show you why in a minute. Or maybe go out to 15 so you can see better. Hit window and then go negative, let's go negative 15 to 15. With a scale of 1, just to help us see what's going on here. Yeah. Did you say why do you hit window? Oh, just hit graph. Alright, so these problems, before we keep going, okay, these problems are looking for two things for the answer. It's looking for all possible zeros and then the one correct zero, okay? Or it's possible as a cubic function, it could have 3 zeros, okay? So you have to check, sometimes you have to check a lot of them. So, we're looking for approximately where this graph intersects. Now that you see nothing's going on out here in terms of it crossing the x at any of these other values, I would zoom box this area here from your 0 over to, actually you don't even have to zoom box. You can just go change your window again from x being 0 to x being 5, let's say. Alright, so I know over here, okay, this is 0, so I know this is 1, 2. So I need something that's a little bigger than 2, but less than 3. So what values over here are bigger than 2, but less than 3? 7/3. So I'm going to write that I'm checking 7/3, okay, because it looks like a possibility that could be 1. Okay, I don't know for sure, but I'm going to check that one. Okay, so to do that, we use synthetic division. Okay? Well, technically speaking, well, yeah, we need to use synthetic division first. Okay, so I'm going to put 7/3 in the box, or 7/3 in the box. Then I'm going to write down all my factors, and I'm going to do synthetic division. 3, -7, 6, -14. Alright, so somebody work out this synthetic division for me. Talk me through what I need to do. Okay, I got 0. So that means then that x is equal to 7/3, or x minus 7/3 is equal to 0. So x minus 7/3 is a factor. Okay. And then we could also say that 7/3 is a 0. Okay, all this wants you to say is that which one you picked is all these questions are specifically asking for. So all you would need to do is then go through and say 7 over 3 is the one that's actually one of the answers. Okay, so you list all possible ones, then you say which one actually is, okay, for these problems. And then we'll do another one here that's a little harder as well. You could then go through and check different ones. Once you get one factor, if that, like, okay, trying to say this as easy as possible. If this graph had crossed the x-axis in multiple places, once I get one factor, I can use the division algorithm to find the rest. So I could use what's left over here to help me factor it out and find the rest. Okay, I'm going to, hopefully the next problem we do, it'll allow us to do that. I'm just trying to let you know now. I don't even know if we'll get through this whole problem, so we might have to finish it tomorrow. Hold on really quick. Let me go ahead and give you guys the problems that we'll do tomorrow, and then we'll finish up the last couple things tomorrow. But I'm going to try to start this problem just because these do take a little longer. Yeah. Your homework problems are going to be 7, 9, 13, 17, 19, 21, 27, 35, 39, and 41. Okay, we haven't done these last two types yet. We're working on the stuff that's like up to 35 now. I'm going to go ahead and try to set up this problem, and then we'll finish it tomorrow. 36. F of x is equal to 6x to the fourth minus x cubed minus 6x squared minus x minus 12. Okay, so on top I need the factors of the constant coefficient, which is negative 12. Fourth. So factors of negative 12 over the factors of the leading coefficient, 6. So factors of 12. And then factors of 6. Okay. So now you got to list off all possible ones. I'd probably start a whole new line here. So plus or minus 1, plus or minus 1/2, plus or minus 1/3, plus or minus 1/6, plus or minus 2. Now, here's the thing. 2 over 2 is what? I do not write it again. Okay? So 2 over 2 is already taken care of with this one. 2 over 3 I don't have yet. It's plus or minus 2 over 3. 2 over 6 is 1/3. I already have it. Don't need it. 3 over 1, so plus or minus 3. 3 over 2, don't have it yet. 3 over 3 is 1, don't need it. 3 over 6 is 1/2, don't need it. 4 over 1 is 4. 4 over 2 is 2. 2 is already taken care of. 4 over 3 is not taken care of yet. 4 over 6 is 2/3. That's already taken care of. 6 over 1 is 6. 6 over 2 is 3. 3 is already taken care of. 6 over 3 is 2. Already taken care of. 6 over 6 is 1. Already taken care of. Okay? So as you go, you are not going to have as many. Okay? 12 over 1, still need it. 12 over 2 is 6. Already done. 12 over 3 is 4. Already done. 12 over 6 is 2. Already done. So there's all my possible factors. Okay? I know we're going through this kind of fast. So at this point what you would want to do is graph this on your calculator. I'd say go ahead and type it in. as a graph, so that way it's there when we use it tomorrow, because I don't think we're going to get through much more of this. Okay, and you're going to want to change your window to go out to negative 13 to 13 for the x values because of that 12. Just to check it, make sure. Okay, once you have that, I would say change your window to be somewhere in this area, like x is negative 5 to 5. Okay, there's nothing out here at the 12 in either direction, so I don't need anything else. I can bring it in, probably even smaller than 5, but 5 will work. So negative 5 to 5. That's fine. So what numbers look like possibilities here? So 3/2, and this isn't necessarily saying that they are, but just pulling out ones that you think are possibilities. So you're saying positive 3/2, negative 4/3. Okay, this could possibly be negative 3/2, so I would say write it down just to check it. But I would say probably these two are going to be the ones that we actually need, most likely. We would check these still by synthetic division, which we'll do tomorrow. We'll wrap this one up, and then we'll do 2 more examples for the upper lower bound, and then the synthetic division to, well, yeah, anyways. So those are your problems. We should get through them tomorrow. If you want to start them tonight, that's fine. And then use tomorrow if y'all have something to study for.